Hello, students. We are in lesson 63, and we're discussing the circles and completing the square, and the different formulas and forms of that we can get to that will help us understand what we're looking at. So as you can see, when we review the development of the equation of a circle by using the distance formula, here's the distance formula right here, we've got the equation of a circle with a central point, an origin of 2, 4, and a radius of 3. Now, when that is, when we take it from the distance formula to standard form, which is what we typically write for the circle, we see really readily that we can find the center of the circle. The points are obvious. This is going to be a positive 2, positive 4 is our center or origin of the circle. And then the radius is 3. And we can tell from inspection, just looking at it, that the standard form is very useful for that. So what happens when we are given the general form of a circle? We can't really do anything with it, right? It doesn't tell us the information that we need to know like the standard form does. So we're going to learn how to take a general form of a circle and put it back into standard form by completing the square twice. And then that is going to give us the information we need to find the origin of the circle and the radius of the circle. So that's what we're doing today. We're just taking equations in general form and putting them back into standard form so that we can get the information we need in order to draw the circle wherever we need to draw it. So let's begin with our first example problem. So here's our first example problem, and we are given this formula in general form, or an equation in general form, and it's the equation of a circle in general form, and we are asked to put this back into standard form by completing the square. And then we are going to graph the circle afterwards to show that we understand the information as it's presented to us. So let's do I'm just going to do the steps and then illustrate them to you. So the first step that you want to do is just rearrange by variable, which just simply means to put your x terms together and your y terms together. The next step is to set it up to complete the square. So I have the x terms together, x squared minus 6x in parentheses with a little space left for that third term, and we're adding that to. And be sure whenever you put this together that you make sure your operation is a positive sign. And you might have to do some calculation there if it is not. But you want to make sure that you take care of that. And that's in its proper place. Most of the time it's probably going to be a positive sign, but if not, you might have to address that. So now you put the y's here, and you have that third space for that term that's coming up, and then we took this positive 21 and subtracted it and moved it to the outside. So we are set up to complete the square twice. So the next step is actually completing the square. So I'm just going to highlight these are actually the steps so you don't get them confused. This is instructions. It's not part of the formula. So let me move over here to the side and show you what I did. I took that middle term. Remember, we take the middle term, divide it by 2. And then we square it. And that gave me a plus 9 for my x term. And I took the middle term, divided by 2, squared it, and that gave me plus 16 for the y term. And then you just add both of those to the right side. So then that is your completion of the square. Now we do the final step, which is to factor it so that we can get to our origin and our radius. So the final step is where we factored it, and we factored this as x minus 3 squared, and this is factored as y plus 4 squared, And then our result here, when we combine these, we get 4. And we know that 4, this term has to be squared. 4 is 2 squared. So that has to be squared as well. So don't forget that you have to have the exponent of 2 on whatever this number is. So it should be a perfect square. If not, you might have to play around with it a little bit. So that is going to tell us now our origin and our radius. And our origin is going to be the opposite of these numbers here. So our origin is going to be 3, -4 with a radius of 2. And that is all it takes in order to get it back into standard form where we can find the information that we need to easily graph a circle. So let's graph that circle. So this is us graphing the circle where it's supposed to be, and that is at 3, -4 with a radius of 2. And I like doing it on a graphing paper because it's really easy to find the point, and then you can go up to, you can create kind of a cross. You can just put a little point here and a point here and a point here, and then you can connect the dots to make your circle. And that makes it a lot easier to draw a circle on graphing paper. So we may do a little bit of that just to see, we may not. I need to look at the problems that we're given to find out. But that is how one would go from general form back into standard form so that you can then graph the circle much more easily. So here's the second problem, and I went ahead and completed it for you. This is a situation where you have a combination at the end for your radius that isn't a perfect square. The solution here is 7. -6 plus 4 gives you -2, -2, and 9 gives you a +7. So the only way to handle that on paper without sticking it in a calculator is to find the square root of 7 and then square it. That is the only way to give it this exponent of 2. And that's the only way that would equal 7, right? Because square root of 7 times square root of 7 is 7. So that means that for this circle, we have a origin that is -2, +3, and then a radius is going to equal the square root of 7. And that's what you would have there. So that's a little bit more difficult to graph because you really don't know what that is. Now, in this situation, what I would probably tell you to do if you're told to graph it is to go ahead and pull up your calculator and put in 7 square root, and you get 2.64, which would be 2.65 when you round it. So you kind of know approximately how long to make that radius if you have to draw a graph for it. So then you could say that equals 2.65. If you rounded that up one more time, you could say that was to one place. You could technically, well, I guess it'd still be 2.6 because it was 2.645. So it'd still be 2.6, right? So 2.6 would be about 2.5. So that's a little bit easier to graph. So you could graph it at about 2.5 so that visually, you get that thing that you're looking for if you're told to graph it when you have a square root issue like that. Go ahead and stick it in the calculator to find it and then give me an approximation. And that's probably what your professors in college would expect also, or your instructors there would be for you to go ahead and find the square root of 7 and then to graph it with that approximate value. So that's how you would handle one of those that isn't a square or a perfect square on the right side of the equation. Let's do another one. So in this final instance, we are given a general form that has a lead coefficient on both the x and the y. Now, when you have a situation like this, you are going to set it up like you normally would, but then you're going to divide by the greatest lead coefficient. Now, it just so happens that in this problem, both of the coefficients are the same number. So it makes it easy when we divide both of these by the same number, we can get down to 1 that way. And hopefully that'll be the case. whenever you come across more of these, that they'll have the same lead coefficient. So it gets a little bit more difficult if they're different. Then we continue with the completing the square. And here we know we have to take half of this, that'd be a negative 1/4 to make, and then that would make squared a positive 1/16. So when we factor it, that'd be x minus that 1/4 squared, x plus 1/4 here because our middle term was positive, squared, and then 24 plus 1 plus 1, that's 26 over 16. When we take the square root of all of that, we can actually, 16 is a perfect square, so we can go ahead and reduce that to 4. But we can't do anything with 26 because the factors of 26 are 2 times 13. So we just have to leave it in the square root format. So what that tells us is we have a circle whose origin is positive 1/4, negative 1/4, with a radius that equals square root of 26 over 4. Now, again, in this type of situation, that doesn't really tell you anything. So you're going to want to pull up your calculator and find the actual radius. And the way you would do that is you'd put in 26 and you would hit the square root, and then you would divide that number by 4. And we get 1.27, which we can round to 1.3. So 1.3, you can visualize that on a graph whenever you take about a third, 1 and about a third of the next circle or the next point. So on your graph, like down here, let's say this is the origin of your circle and you need to do 1.3, you would say 1 and then about a third more. That's your first point, right? And then 1 and about a third more, 1 and about a third more, 1 and about a third more, and then you would connect the dots to try to make your circle like that. Now, fortunately, on a program like this, it's a little bit easier for me to adjust. The other thing that you would want to do is if you have a compass, right? You could take your compass and you can just find this point right here. Just go ahead and measure out 1 and about a third and put your tip of or the sharp point of your compass here and set your pencil of your compass point there and then draw the circle that way. But if you don't have a compass, which, we don't really use it being online quite so much, but you don't really use the compass that much in our class. But if you're doing it at home and you want to make sure you get it done right and you draw that circle well, just put the tip here, measure out about 1 1/3, and then draw that circle. And then that should get you what you need. And in college, that's going to be what your professors are looking for you to do, is to use the compass to draw your circle on a graph. So that is the process that you would use for that. So you would absolutely go ahead and solve this and do a radius. And I may give you the opportunity to give me both answers just to make sure that you know how to do that. And more than likely, I'm going to round this to 1 decimal place just because it's easier. It's going to be easier on you guys to graph if you ever needed to graph it. And I want you to get in the habit of seeing that. Well, that's all we have for lesson 63. So not super difficult. You have pretty much all of the examples of what happens when it's not a perfect square, what happens when it is a perfect square, what happens when this side of the equation is not a perfect square with a fraction. When you have a lead coefficient, you're going to end up with a fraction typically. So we've got some practice problems after this, and then I'll see you in class on Thursday.